Hello and welcome. Today, we're going to dive into something that's really at the core of physical therapy and a lot of medicine. We're talking about how we take a simple movement, like, say, lifting your arm, and turn it into actual hard data. It's this whole journey from just a visual guess to a truly objective fact. And believe me, it's way more interesting than you might think.
So, yeah, it really boils down to this one question. How do we get from just looking at someone move to having solid numbers? Numbers we can track over time, analyze, and use to make really important decisions about the recovery and care.
Okay, so you see this right here. On the left, a simple observation. On the right, all these tables and numbers. Now, they might look a little intimidating, but that data on the right is our goal. This whole explainer is about closing that gap, how we get from what our eyes tell us to what the numbers prove. So, first things first, why even bother with all this, right? I mean, why isn't a quick look just good enough? Well, the answer really comes down to one word: objectivity. Having precise measurements is absolutely crucial. Think about it. It lets a therapist see, without a doubt, if a patient is getting better after something major like a rotator cuff surgery. It helps them set realistic goals instead of just guessing. It gives them a clear black and white way to see if a treatment is working. And importantly, it helps justify the whole plan of care. A visual guess is handy for sure, but the numbers? The numbers tell the real story. That said, let's be realistic. It's not always practical or even the point to whip out the measuring tools. You know, in a busy hospital, the number one priority might just be making sure a patient can get out of bed safely. Or if someone is in a ton of pain, you're focused on helping them, not getting a perfect number for the chart. So what happens in those cases? When you're not doing a formal measurement, how do you even document what you're seeing? Well, clinicians use a kind of system of estimation. It relies on everyone speaking the same language about what functional movement looks like. And a huge term you'll hear is within functional limits, or WFL. This is such a great concept. What it means is that even if a patient's movement doesn't match what the textbook says is normal, it's enough for them to do what they need to do every day. It puts function first. And this example right here just nails it. You've got an elderly woman whose knees bend to about 120 degrees. Now, the book says normal is more like 140. But she can sit down, get out of a car, climb her stairs, all with no problem. So for her, 120 degrees is perfect. It's totally functional. It's WFL. Now, besides WFL, clinicians might use other terms, like percentages, about 75% of normal, or descriptive words. But the key thing is, for any of this to work, the whole facility has to agree on what these words mean. You know, severely limited might mean you have less than half your normal range. Moderately is somewhere in the middle. Everyone has to be on the same page. But estimation can only take you so far. To get that really precise, objective data, you need a specific tool. And the gold standard for measuring range of motion is the goniometer. This is how you really capture the full story. Let me ask you a quick question. Imagine you have two different patients, and they both have a total of 50 degrees of knee motion. Okay? On paper, that number is identical. But does it actually mean their situation is the same? Not at all. And this shows you exactly why. Check it out. Patient A can get their knee perfectly straight. That's 0 degrees, but can only bend it to 50. Patient B, on the other hand, can't get their knee straight. They're stuck starting at 20 degrees, but they can bend it a bit further, to 70. See? They both have a 50-degree arc of motion, but their problems are completely different. This is why just writing down one number is not enough. To get the real picture, you need all this other info. But the most important thing, the thing you absolutely cannot skip, is recording both the start and end positions. That's what tells you the true arc of motion and keeps you from getting the wrong idea. Okay, so this brings us to the real nerdy heart of all this. Once we get a number, how do we know if it's any good? How do we know if we can actually trust it? And this is where two super important ideas come into play: reliability and validity. Let's break this down real simple. Reliability is all about consistency. If you measure the same thing over and over, do you get the same result? Validity, on the other hand, is about accuracy. Is the number you're getting actually measuring the thing you think you're measuring? So think of it like this. Imagine you have a thermometer that's broken. Every time you take a temperature, it reads 95 degrees. Every single time. That measurement is perfectly consistent, right? So it's reliable. But if the real temperature is actually 97 degrees, then your measurement isn't accurate. It's not valid. you're consistently wrong.
Now picture a different thermometer. You measure 5 times and you get readings all over the map. 95, 99, 96, 98, 97. The average is 97 degrees, which is the correct temperature, so on average it's valid. But the measurements are so inconsistent, you can't really trust any single one of them. It's not reliable.
The goal, the bullseye, is to be both reliable and valid. You want a measurement that is both consistent and correct. In our little analogy, this is the thermometer that reads 97 degrees every single time you use it. That's what we're aiming for.
And here is the key relationship between the two. You can be reliable without being valid. That was our thermometer that was consistently wrong. But you can't really be truly valid if you're not also reliable. I mean, if a measurement is really capturing the true value, it ought to be repeatable, right?
So how do we actually do this? How do we get these perfect, reliable, and valid measurements out in the real world? Well, it all comes down to standardizing your process. To make your measurements more reliable, you have to make everything the same every time. You've got to use the exact same position for the patient. You have to carefully feel for those specific bony spots to line up the goniometer. You use the same tool, and ideally, you have the same person do the measuring each time to cut down on tiny differences between people.
And this is where all those numbers become really powerful. By taking a bunch of measurements, like you see in these tables, and then using some statistics, clinicians can figure out what the expected margin of error is. And that lets them say with confidence whether a change they see is a real improvement in the patient or if it was just a tiny blip in the measurement itself.
Yeah, it's really important to know the difference between variation that comes from us, measurement error, and the variation that's just part of being human. People are different from each other, and even one person can change from day to day. Good technique helps reduce our error, and good statistics helps us see the real changes through all that noise.
And that really brings us to our final thought for today. We work so hard to create this objective, standardized data, but we're applying it to people who are completely unique. So if every single body is different, with its own history, its own goals, its own needs, what does normal even mean? That's the big question, isn't it? And it's right where the science of measurement meets the art of healing.